Hey, welcome back. Today, we're diving into what could be a massive revolution in mathematics. We're talking about a story that goes back centuries and might, just might, have finally reached its conclusion. It's all about a brand new formula that claims to solve one of the oldest, most stubborn problems in all of algebra.
I mean, just stop and think about that for a second. What if a problem that stumped the most brilliant minds for generations, a challenge that's literally foundational to science and engineering, was finally cracked? Well, that's the incredible possibility we're exploring today.
All right, let's get into it. To really understand why this is such a huge deal, we need to get a feel for the problem itself. The best way to think about it is like this ancient, unscalable wall that mathematicians have been throwing themselves at for centuries. And that wall is the challenge of solving polynomial equations. You know, these equations are absolutely everywhere, from designing a bridge to programming the apps on your phone. And yeah, we can all solve a simple x-squared equation, no problem. But things get insanely difficult when you get to higher degrees, especially when you're dealing with complex, irrational, or repeated roots. For a long time, this has been a hard limit, a real wall in mathematics.
So how have we tried to get over this wall in the past? Well, mathematicians have come up with some pretty brilliant tools, don't get me wrong. But as we're about to see, even the very best of them have some serious drawbacks. Let's take a look at the old tools of the trade and, more importantly, where they just don't cut it.
And this right here really lays out the problem perfectly. On one hand, you've got Newton's method. It's powerful, for sure, but it's really just a guessing game. It gives you an approximation, an estimate, and it only works if you make a pretty good first guess. On the other hand, you have the rational root theorem. It's super precise, but it's also incredibly limited. It only finds the nice and tidy rational roots. If the answer is a complex number or something irrational, it's completely useless.
And this is where our story takes a really exciting turn. A new paper has come out that proposes something that isn't just another tool to add to the toolbox. It claims to be a master key, one designed to unlock any polynomial equation, no matter how ridiculously complex it is.
It's called the discriminant formula of Murad Sultan Ezouidi. Yeah, it's a mouthful, I know, but it represents a completely new way of thinking about this age-old problem. So what does it actually do? This is the absolute core of the breakthrough. The formula basically uses the equation's own DNA, the coefficients, those numbers out in front of the variables, to directly calculate the exact values of all its roots. And it doesn't matter if they're real, complex, or repeated. It doesn't need a starting guess. It just solves it.
Okay, here it is in all its glory. And look, I know it looks incredibly intimidating, but the key here isn't to try and memorize all that notation. Think of it like a universal recipe. It's just a very precise set of instructions. You take the numbers from your equation, you plug them in, you follow the steps, and bam, the exact answers pop out the other side. The process itself is the revolution.
Of course, a claim this big needs some serious proof. So let's see the supposed master key in action. The paper applies it to a fifth-degree polynomial, a type of equation that is famous in math history for having no general solution. This is pretty much the ultimate test.
And this just brilliantly shows how elegant the formula is. You start with this big, messy fifth-degree equation. Then the formula goes to work, basically transforming all those coefficients into a new set of values. And the result? It turns that complex beast into a beautifully simple equation. X to the fifth power equals some number. From there, finding all 5 exact roots, even the weird complex ones, is actually pretty straightforward.
And this slide really says it all, doesn't it? I mean, the results are just night and day. The Ezouidi formula nails it, finding all 5 exact, complex roots, perfect precision. Newton's method? It kind of gets you in the right neighborhood, but it can't give you the exact address. And the rational root theorem? It draws a complete and total blank. It can't find a single root. The new formula succeeds exactly where the old ones fail.
So, what does this all mean for the future? Well, if this formula holds up under all the intense scrutiny from the math community, and it will be scrutinized, the impact could be absolutely enormous, stretching way beyond the classroom. So, let's just recap how powerful this thing claims to be. We're talking about a method that provides the exact roots for any polynomial. The paper shows it working up to the 18th degree. It handles all the trickiest cases, like complex and repeated roots, without needing any kind of head start or initial guess. It works directly from the equation's own structure. It's a complete toolkit for a problem that has never had one.
And this isn't just some random paper lost on the internet. The method has actually been published in a book, that's already being adopted in some European universities, that tells you it's being recognized for its practical, real-world value in solving the exact kinds of problems that have been tripping up students and researchers for years.
Which brings us to our final and kind of mind-blowing question. After this epic quest that has spanned centuries, from ancient Babylon through the Renaissance and right into the modern day, could this really be it? Could this be the final chapter in the long story of solving equations? It's a huge thought, and you can bet the entire scientific world will be watching very, very closely. Thanks for joining us.